Are we in a simulation? This is a thought experiment that you might have run into before, either in another video or somewhere in pop culture. But it's this philosophical thought experiment to get you thinking about this idea. And the thought experiment kind of goes like this. If humans keep making better and better simulations, then eventually we're going to make a simulation that's as good as reality. And once we have that simulation, we'll probably want to run it a bunch of times to test a lot of things out. And so if we have potentially billions of simulated universes and only one real universe, the odds that we're in a simulated universe are much higher than the odds that we're in the one real universe. This theory really gained a lot of popularity recently because Elon Musk started tweeting about it. And he really believes this theory and has come out with a lot of support for it. And that kind of gave this thought experiment a lot of wind, and people started writing articles and talking about it and thinking about it a lot more than they had in the past. Now, this thought experiment, I believe the original creator was Nick Bostrom in like 2003. He wrote a paper, maybe it was an article, I'm not exactly sure. I think the title was something like "Are We in a Simulation?" I'll put a link below with the original article. I'll look for it. His original argument said that if we assume that it's possible to make a simulation and that it's possible for consciousness to arise within a simulation, then one of three things has to be true. Number one, no civilization ever gets advanced enough to create the simulation. Two, any civilization that's advanced enough to make the simulation won't make it for some reason. The third item is that most people are in a simulation. So either nobody ever makes a simulation, the people that do make the simulation never run it for some reason, or three, we're all in a simulation. Pretty much all of us, at least. Now, I think most of the issues with this thought experiment are really in the assumptions at the start of the thought experiment. If you believe the assumptions, the argument's fairly straightforward, but I think there's some real problems with the assumptions that are being made. The first is that, can we even make the simulation? And I think there are some good reasons to believe that we can't make the simulation. The first big reason is I don't believe we can ever make a simulation that will run in real time, or we can never simulate reality as fast as reality will unfold. So imagine we have two atoms, and these two atoms are as close together as it's possible for two atoms to be. All right, they're just right next to each other, as close as possible for two atoms to be without violating, some other law of physics or quantum mechanics. They're right next to each other. Now, these atoms are going to be sending signals to each other like electromagnetic waves, gravity waves, things like that. And these waves are going to travel at the speed of light, which is the fastest speed it's possible to travel at. And so if we look at one update loop of reality, particle one is going to send, a wave, let's say an electromagnetic wave, to the second atom that's very close to it. The second atom is going to update, it's going to have a new state because it's going to be influenced by that wave. And then this new state of particle two is going to be sent back in a form of a different electromagnetic wave, and that's going to update the state of the first particle. And so there's loops from the initial states, then atom 1 updates atom 2, then atom 2 updates atom 3, and that's a kind of a circle. And so if we're going to simulate reality, we have to simulate that loop. But within reality, this loop is occurring extremely fast, because when something happens in reality, it happens immediately. Like when two particles interact, they just interact and then they're changed. There's no processing time in reality, only in computers and in simulations. So when these particles receive a wave, if their state updates immediately, and the waves are traveling at the fastest possible speed over the shortest possible distance, then that update loop is going to happen as fast as it's possible to happen. There's no way that it could ever go faster. So we're going to simulate this by writing down all the laws of physics and then putting these laws into programs and then running a series of programs or logical procedures over, an abstract representation of these atoms, then that loop is going to be much longer, much more complex, and it's never going to be able to go as fast as the one that happens in reality. So I don't think we'll ever be able to make a simulation that can move at the speed of reality. So if we can't make a simulation that goes as fast as reality, then we're never going to be able to do things like simulate the beginning of the universe up to the present. So we'll never be able to make a simulation of an identical universe and simulate it up to the point where people come around. Because even if we could do that as fast as it happened in reality, we'd have to run the simulation for 13 billion years, or more than 13 billion years, before we got to the point where humans came around. So I don't think we would ever run that simulation. I think implicit in the argument is that we'll run the simulation and it'll happen, rapidly. If we're going to run a simulation billions of times, then we're going to have to be able to run it very quickly. And if we can't simulate any one moment of reality as fast as it happens in reality, we'll never be able to simulate all of the moments of reality, at least in the full depth of detail that they happen in. So it is possible that we could simplify our simulation somehow so that we could overcome this initial constraint. We could skip steps or simulate less aspects of reality, or we could simulate a simpler version of reality. And it might be the case that we could get a pretty accurate copy of what's going on in reality with a simplified model. And in a simplified model, we might be able to do things faster, skip unnecessary calculations, and we might be able to come up with a simplified simulation that happens as fast as reality would happen. But we would never be able to simulate reality in its full depth at the speed that it happens at. So that's the first workaround is we simplify the simulation somehow, and hopefully that simplified simulation would be close enough to the full version that it would work for the use of the thought experiment, where you really could create another universe and have people in it and they would be conscious even with a simplified version. So maybe that's possible. The other possibility is that we create a slower version of reality. Now this workaround relies on time being discrete. And what I mean by this is if we take a 1 second span of time and we slice it in half and we look at both halves, things will be different. Particles will have moved, quantum states will have changed, things will be different. And then if we take one of those halves and we slice it again and we'll look again, things will be different. But is there a way where we could keep slicing till we got to a point where when we looked at both slices, everything was identical? Meaning that nothing in that time period had changed. So that's almost like the frame rate of reality. Or can we always slice reality thinner and thinner and still get different versions of reality? If time is continuous, then it's impossible for us to simulate and the thought experiment is over. Because if reality is continuous, that means to fully simulate one moment, there would be infinite states within a single moment, because you could always slice it and things would be different. So you'd have an infinite number of states to simulate, and if simulating any one state took a positive amount of time, then simulating any chunk of time, any span, would require an infinite amount of computations and an infinite amount of time. So there's no way to do it if time is continuous. But if time is discrete and there is a minimum frame rate, then we could just simulate that frame rate at a slower rate. And if you were within that universe, the simulated universe, even if you were able to be conscious somehow, you wouldn't be able to perceive the slower frame rate, because if your consciousness is only existing in the moments that the frame is on screen, so to speak, then if there was time from another perspective inserted in between those frames, you would have no perception of it. And if we were to create a simulation with this slowed down frame rate, that would be a way to work around the time constraint that I'm talking about. But that means we would never be able to create a full version of our universe within a simulation and then speed it up to where we are now. So that's still off the table, even in this other universe. This is just a way to get around the requirement of hitting real time in the simulation. The second issue I have with the assumptions of this thought experiment is, can consciousness be simulated? And I'm not an expert in consciousness. I don't think really anyone is, because there's so many unknowns about consciousness. But there is a really interesting theory that's kind of at the forefront of people doing research into consciousness, and it's called integrated information theory. And it's created by a guy named Giulio Tonini. I believe that's how you pronounce it. And this theory describes the way that consciousness would exist in a physical system. The theory just tries to describe everything about consciousness and then make predictions about how that system would work and what are the attributes of that system. And it's really, consciousness is structured information kind of coming together to form a coherent experience. And it's repeatedly doing this. And so IIT, the Integrated Information Theory, predicts that consciousness is really just a system that can bring together information and then respond to that information in a very integrated and complex manner, and bring all this and bring it together uniformly into a coherent experience. So it takes all this data about an organism or a system, and it integrates it into one complete singular unit. And then this unit can respond to stimuli in very complex ways. And that's really kind of a description of a human. Like if you poked me in the finger with a knife, my whole body would respond, like pain receptors would go off in my brain. I would jump back and hold my finger. I would probably start thinking bad things about whoever poked me, and a whole lot of things would occur. But it's really, those are all indications that I am an integrated system, like my whole body, like that's a sensor in my finger. And then based on that stimulus, my entire system is responding in a very complex and coordinated way to, respond accurately to that, whatever stimuli I was facing. In this case, a poke to the finger. And the prediction of the system is that this integration is really key to consciousness. And if this is true, then it brings into question whether or not you could have consciousness in a computer system where everything is sequential. So within a computer, we're taking a lot of complex ideas and simplifying them down to a series of steps that logic circuits can complete. And every step is independent from every other step, but we just put them together in this very complicated manner so that they end up doing some kind of work that has coherent meaning to the user. But everything about a computer is not constantly updating every other part of the computer. It's static, and it has this one or a few lines of or a few threads that process information, but it does it one by one. It's not all integrated. All the parts of a human are constantly updating all the other parts with their electromagnetic waves, their like gravity, and then in more practical terms, they're sending signals through neurons, blood's flowing, things like that. Everything is working together, and reality kind of keeps everything in constant communication, because reality is kind of taking all the individual parts, all the individual atoms, and then all of the inputs from everything come together to create one kind of moment in reality. So if this is true, I'm not sure that a computer could really recreate an integrated system in a way that would allow consciousness to arise. But that's just my belief. I'm not sure whether integrated information theory is correct, but it does bring into question whether or not any system that's where we have taken hardware and software and separated them will ever be able to be as integrated as reality. Because in my mind, in a human and an animal, the hardware is the software. And because the hardware is the software, they are integrated in a way that can't really be replicated by computers in the traditional manner that we use computers. Maybe in the future we can make biological computers where the hardware is the software, and then maybe we could recreate consciousness, but I'm not sure in a strictly ones and zeros sequential processes running on logic circuits, whether or not that type of system could ever really recreate consciousness. So I don't think I'll lose any sleep, worrying about whether or not I'm in a simulation. But I'll leave you with one final thought. If we were to use the workarounds that I talked about earlier with time and then maybe complexity and create a simulation of another universe, then a really great way to simplify that universe would be by using something like quantum mechanics. Quantum mechanics really puts a ceiling on how complex the universe is. Because at a certain point, atoms, inside of atoms you have particles, but then those particles are really just represented by probabilities. I mean, it's just math. So maybe we are in a simulation, and in the real universe, instead of quantum mechanics, we just have smaller and smaller particles, but they just don't have the computing power to really simulate all the particles. So they just made up some bullshit called quantum mechanics and then used that to simplify their model. So maybe we are in a simulation. Who knows? That's all my thoughts on the subject. If you like this video, please hit like, subscribe. I've got some book reviews coming. A lot of the books we'll be talking about subjects similar to this. I mean, a lot of my thoughts probably come from a lot of the books I read. So stick around and those videos will be coming soon.